Hello everyone, this is Anand Goud, Assistant Professor from Civil Engineering Department and in Institute of Aeronautical Engineering. Okay, so today we are going to discuss about the topic from concrete materials, that is compressive strength of cement. So coming to the course outcome here. So after learning about this particular topic, we are going to summarize the basic physical and chemical properties of construction materials for determining the quality of concrete. Okay, by learning about this particular test, we can decide whether the property of the cement is good or bad, whether we can use a particular cement in the test or not. Okay, that is what the quality of the cement. Next, coming to the contents here. First, we will discuss about the definition of compressive strength, then significance of the compressive strength test on cement, and factors affecting the compressive strength, and procedure for compressive strength testing of cement, and the precautions while testing the cement compressive strength. So now coming to the definition. Okay, so what is compressive strength of cement? So here, compressive strength of cement is the property of a cement which specifies, okay, how much load it can withstand when cement is made into a hardened mass. Okay, so when you prepare the cement as a hardened mass like cube shape, and how much strength it is going to withstand. Okay, so that particular strength we are going to call it as a compressive strength of cement. Okay, so the cement will be mixed with the water and sand, and then we are going to make one one mass like a material like a cube. Okay, then we are going to apply the load, and that whatever the amount of load it is going to withstand, that particular load will be calculated, and from that we are going to estimate the compressive strength. Okay, that is what the compressive strength. Okay, so whatever the load it is going to withstand, that is what called as a compressive strength of cement. Okay, so the process of testing compressive strength of concrete and the cement may be same, but the materials required for preparing the cube are different. So here, when you discuss about the compressive strength of concrete cube, so the procedure is same for cement and for the concrete. The testing procedure will be same, but the materials, okay, whatever the materials you are going to use, depending upon those materials, we are calling it as a cement testing, and this is concrete testing. So in the concrete, we are going to use cement, fine aggregate, and coarse aggregate, right? And water. Now, here in this particular cement compressive strength testing, we are going to use only cement and sand and water. Okay, these are the materials we are going to use to prepare the cube. See, the compressive strength testing of cement is crucial in assessing its quality and performance in construction. So this particular testing will be useful to assess the quality in terms of strength. Okay, and the performance in the construction. Okay, depending upon the strength of the cement, we are going to apply the loads and how it is going to behave. Okay, so that is what we are going to assess, and it helps in ensuring the cement meets the required standards for durability, safety, and structural integrity. So when you conduct this experiment, so after this experiment, you can get the information regarding the standards. Okay, whether it is having the required standards in terms of material quality, in terms of testing procedure, in terms of loads. Okay, so as per this standard specification, whether it is following the requirements or not. Okay, that one thing we are going to know after testing this particular test. Okay, and next one, durability. Okay, so whatever the standards we are going to follow, that is to improve the performance like durability, and to improve the safety in the construction, and to improve the structural integrity, right? So we can know after testing this particular cement cube, we can know whether it is having the required standards, required criteria, whether it is fulfilling the criteria or not, to improve the durability. Okay, so for better durability purpose, and for safety purpose, and structural integrity, whether it is withstanding the loads or not, whether it is stable or not under the loads. Okay, that is what we are going to know after testing this particular cement cube. Okay, so now out of that, like one of the major property we are going to check is quality assurance. Okay, so the compressive strength is a fundamental property that determines the load bearing capacity of the cement. So quality, how we are going to assure the quality of the cement in the construction. So by checking the different tests like soundness, okay, by testing the cement quality, cement composition, okay, and one of the tests is compressive strength. So by conducting this particular test, we can determine whether the required load is resisting or not. Okay, so that is the one of the fundamental property. Okay, when you use the cement in the construction. Okay, and next one, it ensures that cement meets specified standards set by organizations like IS code or else ASTM or European standards. Okay, so now whenever you test the cement cube, so we can know whether this particular test is cement is satisfying the criteria which is mentioned in the different organization like Indian standard. Suppose if you take our code book, that is Indian standards, so they have mentioned different specifications depending upon the environment, depending upon the type of structure, okay, and depending upon the quality of the materials. So they have set some set of rules and standards. So we have to follow that particular standards whenever you use the cement in the construction. Okay, like that we have different organization like American testing materials. Okay, and next one European standards. They have different code books. Okay, in that code book they have mentioned different types of guidelines to prepare or to conduct the cement testing and to use the cement in the construction. Right. Okay, so we have to check those particular specifications after testing. Okay, next one, structural durability. So this is the another property we are going to check. Okay, see, cement with adequate compressive strength contributes to the long-term stability of the structures. Okay, so whenever you test the cement cube, so it has to possess minimum required strength, right? So if it is satisfying the particular adequate compressive strength, then we can use that particular cement in the construction, and we can get some amount of knowledge regarding the long-term stability of the structure. Okay, if the strength is high, then we can apply the more loads, or else that particular concrete or that particular cement is going to give more life. Okay, so whatever the intended function is there, so that will be fulfilled if you have high strength for cement. Okay, next one ensures that the concrete mix will have the necessary strength to withstand the applied loads. Okay, so after testing this particular cement cube, you can ensure that the concrete mix will have the necessary strength to withstand the applied loads. Okay, so depending upon the cement strength, we can prepare the concrete, and there we will get some idea whether we have to apply the loads or not, depending upon the cement strength. Okay, so that is what the second point. And next one, mix proportioning. Okay, so it helps in designing the appropriate mix ratio of cement, sand, and aggregates for concrete production. So after testing the cement cube, okay, if it is giving less strength, then we are going to change the mix proportions. We are going to change the quantities of cement or fine aggregate or coarse aggregate or water content. Okay, depending upon the strength you are going to get after testing, right? So without testing, you cannot decide whether this mix proportion is giving good results or not. Okay, so after testing, you are going to analyze the cement cube and loads you have applied, and then you are going to get some idea. Yeah, this is the one of the materials which is affecting the strength, okay, of the concrete. So while producing the concrete, while preparing the concrete, you are going to change the mix proportions based upon the strength criteria of the cement. Okay, this is one of the factor. And next one, optimizes the water cement ratio to achieve the required strength. So if the strength is more or less, okay, depending upon that strength quality, we are going to optimize the water cement ratio. Okay, so this is one of the major factors which is affecting the strength of the concrete, right? So that is why we are going to change the water cement ratio to get required strength. Okay, and next one, performance prediction. Okay, so here testing provides an estimate of how cement will perform in real world conditions. Okay, so after testing this particular cement cube, okay, see, while production in the laboratory itself, they are going to check the compressive strength of the cement and all the properties they are going to check, and they are going to supply the cement. Okay, but still while transporting, okay, while handling that particular cement from the construction, I mean from the manufacturing plant to the construction site, so there are a lot of other factors are affecting the cement property. So we have to check the strength again, whether it is suitable for the construction or not. Okay, so and next one, here this particular testing will give the idea about how it will perform in the construction after constructing the buildings, how it is going to perform. Okay, that is what we are going to know when you cast the cement cube and when you test it. Okay, and next one, identifies potential defects or inconsistencies in production. So if the quality of the cement is not good, then it will give some abnormal results in the testing, right? So depending upon the particular testing results, you are going to change, or else you are going to identify if it is having any voids, or else if it is having any defects in the cement cube, or else in the cement. Okay, that we can identify before the usage of cement in the construction, right? Yeah. And next one, compliance with standards. Okay, so compliance with standards is nothing but necessary for certifying the cement batches before they are used in the construction. So now we are going to check whether it is complying with the standards of Indian code or else any other particular codes. Okay, so it is necessary for certifying the cement batches before they are used in the construction. So depending upon the cement quality, okay, only we are going to certify that cement, whether it is having good quality or not, whether we can use that cement or not. Suppose if it is not giving the good results, then we have to change the chemical composition. We have to change the composition ingredients in the cement while manufacturing itself, so that you can take the required remedies while manufacturing itself. Okay, so this particular testing is also very much needful in certifying the cement quality. Okay, and next one, it ensures safety in critical structures like bridges, high-rise buildings, and dams. Okay, so this particular testing will be useful in critical structures like bridges and high-rise buildings and dams. Okay, so these are one of the some of the major constructions, right? Okay, so like bridges and high-rise buildings, okay, and dams. Okay, so when you construct the major buildings, major structures, okay, we need to take care of the quality of materials. So now if you test this particular compressive strength of cement, it is going to give some idea, and depending upon the quality of the cement, we are going to suggest to use in the different structures. Okay, and next one, economic consideration. Okay, so here it helps in reducing the wastage by ensuring only required amount of cement is used. Okay, so suppose if the quality of the cement is tested in terms of compressive strength cement, suppose if it is giving more strength. Okay, so if you want to produce high strength cement, then we are going to change the chemical composition, right? We are going to use some other mineral mixtures, or else we are going to change the chemical composition of the cement. So here we are going to spend some amount to produce the high quality cement. So whenever you need low strength cement, then there no need to spend high amount, no need to add extra ingredients to improve the strength. So depending upon the quality required, okay, depending upon the requirement only, we are going to prepare the cement, and depending upon the quantity also. Okay, the quantity is also very important. Okay, while testing the cement, you are going to add different materials like sand. Okay, we are going to use sand also, right? So that will give some idea about the quantity of the cement. Okay, it will reduce the wastage. Okay, and next one, avoids excessive cement usage, which can increase the cost unnecessarily. So if you use more cement, okay, without any requirement, okay, that will increase the cost of the product, cost of the construction project, right? So there, if you get some idea about the compressive strength of cement, then we can limit the usage of cement, so that we can reduce the cost of the project or construction. Okay, so these are some of the factors which is which are influencing the compressive strength of cement. Okay, so that is these are the factors which are useful while testing the compressive strength of cement. Okay, this is what the significance. Okay, next one, factors. Okay, so what factors affect the compressive strength of cement? Okay, so why sometimes we can see that the results are abnormal, like it will not give required strength, or else it will give more strength sometimes. Okay, so that may not be useful. So okay, if the cement strength is not good, then we have to limit the application. Okay, we cannot use for the important structures. Okay, so what are the factors? Okay, Now see, one of the major factor is water cement ratio. Okay, this is one of the major factor which is affecting the compressive strength of the cement, because if you have more water cement ratio while mixing the cement particles, what will happen? Some amount of moisture content will be blocked like this. Okay, suppose these are the cement particles. Okay, and if you add excess cement water content, then that water content will be flocculated. See, the cement particles will be flocculated due to the moisture content, and each and every cement particles will be like this. See, okay, it will form a closed mass like this. Okay, chain like mass. Okay, and in between these particular particles, here you will be having the moisture content. Okay, so this moisture content will lead to the pores. Okay, after preparing the cement cube like this, and it is carrying the moisture content. This moisture content is not reacting with the other cement particles. It is blocked completely, right? So now what will happen? Due to the blockage of this moisture content, the surrounding cement particles will not get the sufficient water content to complete the hydration process, right? So that is why this will reduce the strength of the cement. If the cement particles are not hydrated properly, then automatically the strength will be reduced, right? Yeah. So this is the one of the problem. If you have more moisture content, then it may, okay, this is not the only mechanism, but one of the factors, okay, one of these particular factors will be happening in the cement. Okay, so we have to take care about the water cement ratio also. Okay. Yeah, so with the time, what will happen? This moisture content will be evaporated. Okay, and here you will get the void, and that will reduce the strength when you apply the load. Okay, it will break, or else you will get the cracks nearby that particular area. Okay, so that is what one of the problems if you take incorrect water cement ratio. Okay, or suppose if you add less water cement ratio, then what will happen? So there will not be sufficient moisture content to complete the hydration process. Right? Okay, so to complete the hydration process, every particle needs some moisture content so that it can produce the hydration products, and those hydration products will be helpful in increasing the strength. Right? So we have to add correct proportion of moisture content, that is water cement ratio. Okay, and next one, cement sand ratio is also very important. Okay, because if the sand is more, then that will affect the bond. If the cement is more, that will affect the cement quality, like it will develop the drying shrinkage. Okay, when you add a cement content more, then that will encourage the drying shrinkage. Okay, if you add more cement content, it needs more water content, and whenever after casting the particular cement cube, due to the evaporation of moisture content, some cracks will be forming due to the drying shrinkage. Okay, so take care when you add the cement and sand quantities. Okay, and next one, type and grade of sand. Okay, so which type of sand you are going to use and grade of sand. Okay, normally we are going to use zone 2, okay, which is having a rough surface. Okay, and type of sand also very important. And next one, manner of mixing. Okay, how you are going to mix the cement, whether you are mixing manually, whether you are using any particular machines. Okay, so depending upon the mixing quality, also the strength will be affected. Okay, and next one, shape and size of the specimen. Okay, normally we are going to use cement cubical shape. Okay, and next one, curing condition. So after casting the cubes or whatever the component, so curing is also very important. Curing is nothing but here application of moisture content to complete the hydration process, right? So whenever when the cube is casted, it has to cure properly. Okay, we have to apply the moisture content continuously to complete the hydration process. Suppose if the curing is not done, if the water application is missed for a few days, then what will happen? The moisture content needed for completing the hydration process will not be there. Okay, so if the hydration process is not done, then the strength will be reduced. So curing is also plays a major role in the strength improvement. And next one, age of the specimen. So at what age you are testing the specimen? Okay, so we have different curing periods like 3 days and 7 days and 14 days and 28 days. Okay, like this, depending upon the time. Okay, we are going to test the cement cube and we are going to test the compressive strength. Okay, and next one, rate of loading. So rate of loading is one of the major factors. Okay, so some people may neglect, but how fast you are applying the load. Okay, whenever you apply the load slowly, the capacity will be different, and when you apply the load suddenly, okay, when you apply the rapid impact loads, then it behaves in a different way. Okay, so that is why rate of loading will be one of the factors which is affecting the compressive strength. Okay, so those are the some of the factors. Okay, and now coming to the compressive strength test of cement. Okay, coming to the procedure, how we are going to test. Okay, as per the Indian standard, we are going to follow this procedure. Yeah, see, our aim of this particular testing is to determine the compressive strength of standard cement mortar cube. Okay, so now here we are going to cast standard cement mortar cubes as per IS code guidelines, and we are going to check the compressive strength. Okay, next one, coming to the apparatus. Okay, to test this particular cement mortar cubes for compressive strength, we need following apparatus. The first one is cube mold of size 7.07 centimeters by 7.07 centimeters by 7.07 centimeters. Okay, so that is the cube mold we are going to use. In this picture you can see this is the cube mold. Okay, and next one, compression testing machine also we are going to use. Okay, and weighing balance of which is having the accuracy of 0.1 grams. Okay, weighing balance will be used. And next one, vibration machine. Okay, vibration machine to compact the cement mortar to remove the air voids. Okay, and measuring cylinder will be used for measuring the water content. Okay, and next one, trowel and tray. Okay, these are used for mixing the cement mortar. Okay, and for placing the cement mortar in the cement cube mold. Okay, so for this particular testing method, we are going to use the code book of IS 4031 part 3 1988. The title of this code book is Methods of Physical Test for Hydraulic Cement. Okay, so in this code book, the procedure which is used for testing the compressive strength of cement will be mentioned. So everyone follow this code book for more guidelines. Okay, and next one, materials used. Okay, so which materials we are going to use for casting the cement mortar cube. Okay, see, first material is cement, and second material is sand or fine aggregate. Okay, and water content. Okay, these are the three major materials we are going to use for casting the cement mortar. Next one, here you can see this is the cement cube mold. Okay, which is having a dimensions of 7.07 width, 7.07 height, and 7.07 length. Okay, these are the three dimensions we have. Okay, and next one, see here, this is the cement cube we are going to cast. It is having a dimension of 7.06 mm and 7.06 mm and 7.06 mm. Okay, three dimensions will be same. Okay, and this is the compressive testing machine. Okay, so by using this testing machine, we are going to conduct the experiment as we have conducted in the concrete testing also. Okay, so now coming to the procedure here. First, before conducting this experiment, first we have to prepare the cement mortar cube. Okay, so first preparation of test specimen for each cube. Okay, now take the quantities of materials with ratios of 1:3 as follows. Okay, here we can take different ratios, 1:2, 1:3, 1:4, depending upon the strength requirement. So here I am considering 1:3 ratio, 1 unit of cement and 3 units of fine aggregate. Okay, so now see, cement quantity I am taking 185 grams. Okay, 185 grams of cement I am taking here. And next one, standard sand. Okay, the fine aggregate quantity I am taking as 555 grams. Okay, 3 times of 185 grams. Okay, it should conform to the IS 650 and 1991. So when you take the fine aggregate content, so you just go through the guidelines mentioned in the IS 650 code book. Okay, now this is the quantity of the fine aggregate. Okay, now next, water content. So water content will be considered by using this formula, that is P by 4 plus 3% of combined weight of cement and sand. Okay, so by combining these two weights, okay, 185 plus 555. So whatever the weight you are going to get from that particular weight, we have to take P by 4 plus 3%. So here P is nothing but what? P is nothing but here standard consistency. Okay, so for cement, first we are going to conduct the standard consistency test, right? So there we are going to know about the quantity required for testing the for preparing the cement, consistent cement, right? So that particular percentage will be taken as P. Okay, and next P by 4 plus 3, if you do this calculation, that much percentage will be calculated from the total weight of these two cements. Okay, so mix the cement. Okay, whatever the water content we got after this calculation. Okay, so now mix the cement and sand with a trowel on non-porous plate for 1 minute. Okay, so after getting the weight of the water content, now we have to mix the cement and fine aggregate with water content. Okay, so after mixing this particular cement materials, okay, after mixing those materials, okay, now you prepare a consistent cement mortar. Okay, next then add water to the mixture of cement and sand and mix until the mixture of uniform color is obtained. So first we are going to mix the cement and fine aggregate or sand, okay, on non-porous plate, okay, in a dry condition. Okay, first mix these two materials in a dry condition. Then after mixing these two materials in a dry state, then add water to these two materials. Okay, then mix it thoroughly, okay, to get the uniform color and uniform mixture. Okay, the cement should apply all over the surface of the fine aggregate. Okay, so after mixing these two materials, add the water and mix the particular cement mortar gently and thoroughly to get the uniform mixture, okay, and uniform color. Next, here whenever you mix the particular cement and fine aggregate with water, so the time of gauging shall be, in any case, should not be less than 3 minutes or should not be more than 5 minutes. That means here gauging time is nothing but the time lapsed between the water added to the mix and casting of cubes. So when you add water to the cement and fine aggregate, so we have to note down the time, and while mixing, okay, after mixing, we are going to place the cement mortar in the cube, right? So the time taken in between these two activities, at the time of water to the placing of cement mortar in the cube. So till that particular time, how much time it is taking? The time should not be less than 3 minutes, and it should not be more than 5 minutes. It should be 3 to 5 minutes, and this time is called as a gauging time. Okay, is it clear? Yeah, here. So the time of gauging is nothing but the time added. Okay, it is a time whenever you add the water to the cement powder to the time when you are going to place the cement mortar in the cubes. Okay, it should be done within 5 minutes, 3 to 5 minutes. It should not take more than 3 to 5 minutes, because it will start setting. Okay, after 5 minutes, it will start setting. Okay, it will harden, it will gain the strength. That is why we have to limit the mixing time and placing time. Okay. So now, see, after mixing this particular cement and fine aggregate with water, now simultaneously, okay, or else before the mixing of cement or sand, you take the cement cube mold and apply a thin layer of oil to the interior faces of the mold. Okay, so before pouring the cement mortar, you just apply the oil or grease on the interior faces of the mold. Okay, and place it on the table of vibration machine and firmly hold in position by means of clamps. Okay, now after applying the oil on the inside walls of the cement mortar cube, now place this total mold on the vibrating machine. Okay, on the vibrating machine. Okay, like this, you place the mold and hold it firmly. Now place the entire quantity of the mortar in the hopper of the cube mold and compact same by vibrations. Okay, for a period of 2 minutes. So now after placing the cube mold on the vibrating machine, now place the total quantity of the mortar in the cube mold. Okay, then apply the compaction by means of vibration. Okay, just to switch on this machine and it will compact the cement mortar which is placed in the cube mold. Okay, you just compact it, okay, by switching on the machine. Okay, so that the air voids which are blocked during the mixing time or else during the placing time will be eliminated. Okay, now it will be compacted. Now add excess amount of water because it will be compacted, right? So whenever it is compacted, then the height of the concrete mortar will be reduced. So add excess amount of cement mortar again and again. You just compact it. for 2 minutes. Okay, so at the end of the vibration, remove the mild mold together with the base plate from the machine and finish the top surface of the cube in the mold by smoothing the surface with blade of trowel. Okay, so now after completing the vibration process, you just level the surface of the cube mold. Okay, you just level it along with the cube mold and then smoothen the surface. Okay, smoothen the surface, and if you want to mark it with any identification, then mark now. Suppose sometimes you are going to mention the percentages like 1:3, or else some people will give notations to that. Okay, depending upon their project type. So here, if you want to mark any identification marks, you can mark it now. Okay, now keep the filled mold in the atmosphere of at least 90% relative humidity for 24 hours. Okay, so now take out the total setup and keep it in an open environment, okay, which is having the humidity of 90%. Okay, now after completion of the vibration, we are going to place it for 24 hours. Okay, place it for 24 hours in the open environment. Now also maintain the temperature of around 27 degree plus or minus 2 degrees. Okay, we have to maintain this particular temperature, that is 27 degrees Celsius. Okay, next, at the end of this particular period, after 24 hours, okay, remove the cubes from the mold and immediately submerge in clean fresh water. Okay, and keep there until taken out just prior to the break. Okay, so now after 24 hours of time, you just take out the mold completely, okay, and unmold it to get the cube. Okay, so unmold it and take out the only cube, cement mortar cube, and place it in the fresh and pure water. Okay, you just place it in the fresh and clean water for curing purpose. Okay, so depending upon your requirement, like 3 days or 7 days or 28 days or 14 days. Okay, depending upon our requirement and time, we are going to cure it for different curing periods. Okay, so before testing only, you have to take out the particular cube from the water, that is from the curing tank. Okay, so now after they are taken out until they are broken, the cubes shall not allow to become dry. So before testing only, we are going to take out the cubes. So without any other particular considerations, okay, it should be completely continuously cured. Okay, we should not engage in the making the cube dry. Okay, so continuously we have to apply the moisture content, okay, in the curing. Okay, with this we have completed the casting of cement mortar cube. Okay, now we will go through the testing of cement mortar cube. Okay, see, after preparing the cube, okay, now after curing the cube, now take out the cube, and before testing you just take that cube and wipe out the moisture content which is placed around the surface of the cube. Okay, just to wipe out, and you just dry it for 2 to 3 hours. Okay, so before testing you have to dry it for some time, okay, by wiping out the moisture content, okay, to avoid the unnecessary abnormal results. Okay, now after wiping out and after drying it for some time, now place the test cube on the platform of compression testing machine without any packing. Okay, so now here, see, like this we have to place the cement mortar cube in the compressive testing machine between the two plate ends. Okay, now between cube and steel plate ends of the testing machine. So here, while placing the cement cube, okay, on the plate ends, you have to check whether it is clean or not. It should not contain any particles, okay, because that is going to affect the strength. Okay, so we have to clean the plate ends and you have to place. Okay, now apply the load on the cement mortar cube after placing this particular cube in the compressive testing machine. Apply the load on smooth surface on the cube steadily and uniform, starting from 0 at the rate of 35 Newton per mm square per minute till cube fails. So now here we are going to apply the load steadily. Okay, we are not applying the load suddenly. Okay, we are not applying the impact load or a sudden load. Okay, we are increasing the load steadily. Okay, like so. And what is the rate of the load means here 35 Newton per mm square per minute. Okay, for 1 minute we have to apply 35 Newton per mm square of load. Okay, so until the beam, the cube fails. Okay, so when you have to stop the application of load means whenever the cement cube fails, at that time you have to stop application of loads and make a note of that particular load. Okay, so now test 3 such cubes at the end of 3 days of curing. Okay, so now and 3 cubes at the end of even 7 days of curing. Okay, 7 days of curing, and if needed 3 cubes after 28 days of curing. So now here we have to test the cubes according to the required curing period. So some people will test the cubes for 3 days, and some people will test the cubes for 7 days, and some people will test the cubes for 28 days. So depending upon our requirement, we have to cast the cubes and we have to cure it for 28 days. And for every set of testing, we should cast at least a minimum of 3 cubes. Because while placing, while casting, while preparing the cement cubes, you may do some mistakes. It will lead to a wrong results. So we have to take 3 such cubes for each and every sample. Okay. So now record the crushing load. Now we have to record the crushing load for each and every cube. Okay. So now calculate the compressive strength. Okay, of each cube by dividing the crushing load by crushing area of the cube. Okay, so now we are going to calculate the compressive strength of the cube. Compressive strength of the cube by taking the load by area of the formula. Okay, so load means here crushing load. Okay, wherever the cement cube is failing, that load will be considered here. And area means the surface, top surface, because wherever you are going to apply the load, that particular surface will be taken here. Okay, by using this, you can calculate the compressive strength. Okay, now this is the observation table in the testing of compressive strength of cement. See, in the first column, we have to mention the age of cube, whether you are testing it for 3 days, or 7 days, or 28 days. Okay, depending upon the age, we have to mention. Okay, and next one, dimensions of the specimen. So here we have to write, okay, dimensions of the cement, 7.6 centimeters. Okay, this is in centimeters. So here the units are mentioned in the millimeter set. So you can write 70. Okay, approximately 70 mm, and B also 70 mm, and H also 70 mm. Okay, approximately I am writing the number here. Okay, so 70 mm dimension. Okay, age, dimensions, and next one, weight of the cement cube. So here we have to mention the weight of the cement cube before testing. And next one, cross sectional area. So where you are applying the load. Okay, on the top surface you are going to apply the load, right? So 2 surfaces, L into B. Okay, so 70 into 70 will give you the cross sectional area. Okay, that will be taken here. And crushing load, how much amount of load will be applied on the concrete. Okay, sorry, cement cube. And here by using the formula load by area, that means that this load will be taken and the area will be taken. So here you will be finding the compressive strength in megapascal. Okay, depending upon the age. Okay, for 7 days, what is the compressive strength? Okay, and for 28 days, compressive strength. Okay, so this is how the observation table will look like. Okay, next one. So the compressive strength of each cube on the respective test day is calculated by using this formula as we have discussed. Okay, crushing load by cross-sectional area. Okay, and the result will be noted. The average compressive strength of the given cement. Why we are taking average means we are going to cast 3 cubes, right? So we have to note each and every cube result, and we have to take the average of that particular compressive strength, and that will be taken here as a strength. Okay, 3 days strength, 7 days strength, and 28 days strength. Okay, next. So BIS requirements for compressive strength of cement, OPC cement. Okay, so as per IS 268-1 and IS 8122 and IS 12269, the average compressive strength of cement shall be as follows. Okay, so here you can see for OPC, here we have different grades of cement, right? 33 grade cement, 43 grade cement, and 53 grade cement. So after 3 days of curing, if you take 33 grade cement, it should get around 16 megapascal strength. Okay, that is the minimum requirement for 33 grade cement, ideal strength. Okay, and after 7 days, it should give around 22 megapascal strength. And after 28 days, it should not be less than 33 megapascal. That is what the 33 grade cement means. Okay, as per the IS code, if you use 33 grade cement, it should have around 33 megapascal strength minimum after 28 days. And for 43 grade cement, it should have 43 megapascal. And for 53 grade cement, it should have 53 megapascal minimum. Okay, if it is giving this much particular strength, then it is satisfying the conditions requirements of the Indian standards. Okay. Next one, coming to the precautions. Okay, so here the temperature of the room and cube should be maintained. Okay, so while testing the compressive strength of cement cube, here we have to take some precautions. Right, the first precaution is we have to maintain the temperature around in the surrounding environment about 27 degrees Celsius plus or minus 2 degrees Celsius. And next one, the water used for curing should be changed for every 7 days. Okay, so we are keeping it for curing for 28 days, right? So for every 1 week, we have to change the water. And next one, the cube should not be dried before completion of the compressive strength test. So at any point, okay, in the curing period, that cube should not be dried. Okay, it should be continuously moisture. Okay. And next one, if the mixture of cement, sand and water does not obtain uniform color within units of mixing, then mixture should be discarded and the operation should be started from the start. So after mixing, if the mixture is not uniform, if it is not having the uniform color and mixture, then it will be discarded and again you have to prepare a new mix. Okay. And next one, the compressive strength depends upon the proportion and properties of the raw materials used. So the raw material should be selected carefully. So when you check the compressive strength, one of the major factors affecting is the properties of the cement and materials and the proportions. How much proportion you are going to take? How much cement quantity? How much fine aggregate quantity we are going to take? Okay, so these proportions as well as the material properties, individual material properties also plays a major role in improving the compressive strength of cement. Okay, so these are some of the precautions we are going to take while testing the cement compressive strength test. Okay, yeah, and these are the references I have used. And thank you.
Like, share and subscribe. Hit the bell icon for more updates.